This is Math 2 7.4 notes. That's Unit 7, Lesson 4 notes for Math 2. The title is Trigonometry Continued. We are working with the inverse functions. You will need a scientific calculator to work through this lesson. Okay, today what we're going to work on is how to find the missing angles. We've already talked about how to find missing sides using at least 3 different methods that we've done in class. Today we're focusing on how to find missing angles. I'm going to put here a whole number. Typically when they ask you for angles, they will ask you to round to the nearest whole number, but you do want to pay attention on the test what they're asking you to round to. So whole number means no decimal. All right, let's get our right triangle. Remember, these are only used on right triangles, or right triangle trig. Okay. I'm going to label this A, B, C, angle ABC. This is 7, this is 15, and I'm going to put theta. Theta is another, it's just a variable. It's part of the Greek alphabet, just like using X or Y or Z. We use theta quite often when looking for an angle. We do use X as well, so I'm just throwing it out there. So when you see that, theta, T-H-E-T-A, so you know how to say it and it doesn't look confusing and you're not caught off guard. Okay, so when you're finding a missing angle, you do very similar to what you do when you're looking for a missing side. Where is theta? Theta is here. And then from there, label your sides. If in reference to theta, 7 is opposite. Now, is 15 adjacent or is AC adjacent? Well, 15 is automatically the hypotenuse because it's opposite the 90. So we don't have to worry about figuring out what that one is. It is hypotenuse. And then you're going to use your SOHCAHTOA to use what's opposite over hypotenuse. That opposite over hypotenuse is the sine. So this is the one we're going to use. Sine of, always an angle, always. Sine of theta, not a side ever. Sine of theta equals opposite over hypotenuse. And how do we do this? You do not cross multiply, do not, like we've been doing, because theta we don't know. So here is what you do. You do the inverse function. I'm going to write it out for you first. That's what it looks like. Inverse functions, remember we talked about inverse functions undoing each other, inverse operations. So that's what we're doing. We're doing the inverse to undo sine so we can find the angle. What that means is you're telling the calculator, hey, I don't know the angle, but I know opposite is 7 and the hypotenuse is 15. Can you tell me what the angle is? And the calculator figures it out for you. So here's what you do. Make sure it's cleared. Second, your sine key, it should have a little sine -1 on there. And then 7 divide 15. So it looks like that. Second sine, sine -1, 7 divided by 15, and there's your angle, 27.8. As a whole number, that would be 28 degrees. And that's your angle. So that's pretty nifty. The calculator can do the work for you. You tell the calculator, hey, I don't know the angle, but I know the opposite and hypotenuse. Can you tell me what the angle is? And it gives it to you. Okay, let's try another. Number 2. A, B, C. And this time I'm going to call the angle X. Again, it doesn't matter. I'm going to call this side 5, that side 12. And we do the same thing we've done before. We put our mark wherever the angle is. They're asking us for X, so it's there. Opposite the 90 is the hypotenuse. And that makes this not the opposite, but the adjacent. They're both next to it. How do we know which one's hypotenuse, which one's adjacent? Hypotenuse is always opposite the 90, which means 5 has to be the adjacent. So using your SOHCAHTOA, which one's adjacent over hypotenuse? That's the cosine. So that's the function we're going to use. Kids often ask, how do you know whether you're using sine or cosine or tangent? That's how. We mark our angle, we label our sides, and then we pick it. Okay, cosine of X equals 5 over 12. We don't know what the angle is, And a lot of kids go straight to plugging it in. This here, what I'm writing down, is showing your work. So I do need to see that inverse cosine of 5/12. So really quick side note, whenever you're looking for a missing angle, you're going to be using the inverse key. Whenever you're looking for a missing angle, you're going to use the inverse key. Not a missing side, just a missing angle. All right, let's plug it in. I'm going to hit clear, second cosine, sorry, wrong key, second cosine, 5 divided by 12. Your calculator might have an inverse key instead of second key, but it's the same thing. And then 65.3, 66 or 65, it would stay at 65. And that there is your answer. Okay, let's try one more. Number 3. Find angle B. Okay, there's my right angle, that's C. This is B, this is A, this is 12, and that is 7. Find angle B. Always first thing you're going to do is put your marking at the angle they're asking you to find. Here it was theta, which was in corner A. Here it was X, which was in corner B. And here they're specifically telling us to put it in corner B. In reference to B, okay, first off, opposite C is the hypotenuse. If there's nothing there, I'm not going to label it. Which one's opposite, which one's adjacent? Across does not share the angle is the opposite. Next to shares the angle is adjacent. Okay, so we're going to go through and use our SOHCAHTOA and figure out which one doesn't deal with hypotenuse, which one's only opposite adjacent, that is the tangent, so that's how we know which function to use. Tangent is opposite over adjacent, O over H, opposite over adjacent, that's 7/12. Oh, forgot my angle, angle B. You always use an angle. Do not ever do tangent of 12 or tangent of 7. That's not going to work. Okay, we don't know what angle B is, so I'm going to use the inverse key to find angle B. So second tangent, 7 divide 12. Again, we use the inverse key when we don't know an angle. Equals 30.2 with that round to 31 or stay 30. That is going to be 30 degrees. And we will get more practice with this in class. That is it for this lesson.